In this example, we're going to look at cumulative distribution function. F of x is a probability density function defined below. It's a piecewise function. Over 0 to 1 we have x squared plus 1 over k, and from 1 to 2 we have 4 minus 2x over k. So the question asks us, what is the value of k? And then we're going to find the cumulative distribution function of f of x. Then we'll find the probability where x is bigger than 1.5 using the cumulative distribution function. And number 4, we're going to find the value of the upper quartile. So question 1 then, find the value of k. So we know that the total probability over 0 to 1 is going to equal 1. And as it's a piecewise function, we need to integrate the function over its separate pieces. So from 1 to 0 and 2 to 1, integrate those, add them together, it should come to 1. We evaluate this integral, then you will get eventually to an equation that you can solve for k. So k here is 7/3. Finally, we can rewrite our probability density function without the value of k, and it's defined here as you can see. Second question then, we want to find the cumulative distribution function of f of x. So the CDF is found by integrating f of x over the respective intervals for each piece of the function. It's worth noting that the second piece of the function has to equal the total probability over the first one at x equals 1. So what you do then is you integrate the first one from 0 to 1, getting the total probability, and then you add that to the second function, because it's got to be cumulative, and a cumulative function starts at the lower limit, and whatever you evaluate it at, let's say if you evaluate it at 1, then it must equal the probability from 0 to 1. So this is our PDF. So we're going to integrate the first part then from the lower limit to some point x. Note I've used a capital X, and this just stands for a particular point, and as the function's defined over lowercase x, I'm using a capital X because I need to really use a different letter. So this will give a function that when evaluated at a certain value will give us a probability from 0 to that particular value. So here we go then, so from 0 to capital X, so I evaluate the integral, and it gives me x cubed plus 3x over 7. So for the second part, we need to integrate, but this time we need to add the total probability from 0 to 1. So I'm going to integrate it from 1 to x, so that's my lower limit, the second part of the function, up to x, so some point in that interval. I evaluate the integral, and then that's my answer. So in order for this to work, then obviously if I were to integrate this as if we were to evaluate this at a particular value, it won't include the first part between 0 and 1. So what I need to do then is find the probability from 0 to 1 and add it on. So I'm going to evaluate that function at 1 then. So this is the function I've found. You evaluate that at 1, it'll give you a probability of 4/7. You just add that on to your previous answer. So the second part of the function should be that 12x minus 3x squared minus 9 over 7 plus 4/7. So eventually you should get to that answer there, 12x minus 3x squared minus 5 over 7. And then to check the result is correct, evaluate the answer at the upper limit. It's a useful check because this should always equal 1. So you can see here, if I substitute 2 in, remember the cumulative function starts at the lower limit and goes up to the value that you substitute in. So I substitute in here I am finding the probability from 0 to 2, and you see that it equals 1. So that's a good indication. So we can define the cumulative distribution function, which we always use a capital letter for our function, so capital F of x here, where it's 0, lower than, so when x is lower than 0, as our probability density function 0, so will our cumulative be. From 0 to 1 is defined by that expression there, x cubed plus 3x over 7. Between 1 and 2, 12x minus 3x squared minus 9 over 7. And then anything beyond that will just be equal to 1. The probability won't increase anymore because our probability density function stops at 2. So we're going to use this answer then to define our probability where x is greater than 1.5. So as it's a cumulative function, then it's defined for all values less than 1.5. So if we evaluate our function at 1.5, we're going to need to minus it from 1. So 1 minus the probability of x less than 1.5 will give us the answer that we want. So that will be 1 minus 25 over 28, which is 3 over 28. Okay, so to find the upper quartile, all we need to do is write our function equals 0.75, evaluate that in terms of x, and then what we're going to do is obviously just rearrange and solve it so we get a quadratic equation that we can solve in terms of x, and then that gives us two possible values. Now you can see that 2.763 is not valid as it's not over the interval 1 to 2. So we take the second answer, which is 1.236 to 4 decimal places.